Alright, here we are. We have a assembled circuit, small enough to fit the dimensions, and as well we have our 5 wires coming off. All we've done here is quickly hooked it up, and then as well we built a tiny little test board to go with it. So the signals are as per the blue one will be going to the screen. The black and the reds are obviously your power lines or power rails. Over here you have your sound signal, the green, and I've put it here so you can make a quick disconnect. Okay, it's just tied to ground. The yellow wire is again your button wire. Your button is just quickly assembled. One side of the button is connected straight to high, the other side is connected to ground through a resistor, and at the top of that resistor, between the resistor and the button, I guess, is where you connect your signal line, so that way it'll hold it on ground. Otherwise, if you press the button, it goes high. Okay, so all these little wires are just basically jumpers running to there with nice little clips, so I don't have to mess around too much. As well, the whole thing is going to be current monitored, and as well I do have a current limit in case anything ever goes wrong. I don't blow anything up, or I don't cook my chips. So right now I've set it at 20 milliamps. I'm running at about 2.8 because most batteries are not actually 3 volts. If they're especially have a shelf life of a couple of years, they're probably down to around 2.8. So yeah, just keep that in mind. We'll test the circuit at 3 volts, as well as we're going to test it right down to around 2 volts. So keep that in mind as well. Here we go, and we can also throw it on milliamps and microamps if we need to. The circuit is right here, and we'll be able to see the red light and the yellow light function by pressing the button, as well as interrupting or giving it a potential sound signal. And then as well we'll be able to give a screen on and off signal by moving this from the power rail to the negative power rail. So as of right now, in the negative power rail, it will be considered off. Screen is off, unit is off, because the MOSFET on this little unit now shall be controlling it. So let's give it a try. Oh, here we are. So hitting the on button, as we can see, we're powered in. We have 0. Oh. Now we can come over here, take a look. Everything is on. I can guarantee it's on. So we're going to then hit to micros, and you can see there is a tiny little bit of leakage current right now. So we're going to just take a quick look why that is. If you look, there's a resistor here, and this resistor is tying this button here to ground. This button being tied to ground, there's a tiny little bit of leakage current going through that resistor to ground. But on the Digimon, it's not necessarily the same. So we will just lift that, and as you can see now, with that resistor disconnected, we're talking 0 microamps. This thing is completely off. Alright, so for the sake of the test, we're going to need our test board actually assembled, so we will put that in there. And as you can see, 5 microamps is really nothing. We are going to go to milliamps now though, because we are going to turn the unit on. So the first thing to turn the unit on is the screen has to go on. So we pull the screen and we throw the screen in the on position. The first thing we will notice is nothing has happened on the chip. Oh, let's see, we're losing our focus here. Where's our focus going? Interesting. Nothing's happened on the chip, but we do have, well, we have just under a milliamp. What's going on with this camera here? Here we go. We're just under a milliamp. Okay, so the chip is definitely on. There's some current going somewhere. Let's see if we can focus on getting this camera sorted out here, because this is ridiculous. There, it's a little bit better, not much though. Oh, here we go. Perfect. Wow. Okay. Anyways, carrying on with the demonstration. So we got 87 milliamps. Chip's powered on because the screen is right now in the +5, which is the blue wire. Now what we'd like to do is quickly to see what would happen if a sound signal comes in. So we lift this, and immediately you will start seeing sound signals. That's basically because there's AC around here, so it's feeling the AC in the but once it's grounded out, nothing happens. As well, we'll check over here, and you can see that it is using up a bit of current to run such device. Alright, putting the sound wire back, you can hold the button down and cause the yellow lights to increase for your backlight. Alright, now that's step 1, stage 2, stage 3, stage 4, and stage 5, and then off. And again, alternatively, running current, stage 1, stage 2, stage 3, stage 4, stage 5, and off. Right, and that's just now waiting for some sort of signal. Now, one of the neatest things that this thing will do is when you hold, or you have some sort of backlight going on. Alright, we're going to just kind of give it a bit of a demonstration here. And it's going to look mind-blowing when you see it on the Didge. Alright, so you got your backlight. And what's going to happen is when you get sound effects, it's even hard to tell on this camera right now, but you're getting red flashes. Yeah, the camera's not syncing very well on this. But you're getting all sorts of red flashes when you're getting sound signals. Now the neat thing is you can adjust how bright this backlight is. As well, if you don't have the backlight on and sound still happens, you will still just get sound signals showing you stuff's going on. Now this is going to work during actions, this is going to work during whatever. The moment the screen times out again, okay, here we'll just give us a little bit of light so you can see what I just did. I just again moved the blue wire back over. Once the blue wire is back over, you can see our current has dropped right back down. Now, currently this model is using old style LEDs. They are not very efficient, at which point we have ordered some highly efficient ones that are coming in, and we're going to see how much that makes a difference. But this is the basic circuitry. The next thing to do is add a tiny little bit of hot glue to the edges of where these wire ribbons, or basically kind of make the wire into a ribbon just near the device to add some rigidity to these components. So I will do that, and then we'll take some pictures of that. After that, it's basically installing into the Digimon, and I will take some more pictures as I go along.